EDF Renewables has been active in Israel since 2009, 100% owned by EDF Renewables France. We have more than 600 megawatt PV and 100 megawatt hour of battery energy storage systems, or BESS, and are expanding rapidly with a 2 gigawatt pipe of PV and BESS projects in all stages of development. This is a unique microgrid project for a school inside the Tel Aviv metropolitan area. It can provide 1 to 2 days of electricity without a grid connection. The microgrid consists of 20 megawatt hour of battery energy storage and will in the future also include PV installation on the school's rooftops.
This is our first urban microgrid project. Generally in EDF, we're focused on large-scale PV and storage projects, but we hope that these type of projects are going to be more popular and that we're really starting a trend here in Israel. So this project is a great example of what we in the storage community refer to as value stacking. So value stacking means that you take one project and you solve several problems. And we're solving at least 3 problems with this project. First of all, we're doing energy shifting. Energy shifting means that we take electricity when there's abundance, so in Israel this means during the day or in the morning, and we charge the battery, and then we sell it later on in the afternoon when the demand is high and the electricity price is high. So the second problem that we're solving is grid congestion. This project is located within the Tel Aviv metropolitan area. It's an urban area with more than 1 million people and industry, but no electricity producing facilities. And the grid operator is really struggling here to get electricity to everybody. Our facility is providing a really important resource that we can discharge electricity when it's most needed. And the third problem we're solving, the most important and the most interesting, is microgrid. We are providing the ability to completely disconnect from the grid and provide all the electricity need for the school for 1 to 2 days. We want to make sure that the microgrid works and that we're able to completely disconnect from the grid whenever there's a grid failure or whenever the client wants us to disconnect. And in addition, we need to have daily full cycles from the battery in order to get the revenues that we need for this project. So microgrids are always complex, and this was especially complex since it was 20 megawatt hour of batteries that were placed within a densely populated urban area. So we were forced to think out of the box and come up with innovative solutions.
There were many challenges as it was our first project of this kind. For example, we had to choose the location, change its legal designation, and clear it from existing functioning infrastructures. Additionally, inserting a relatively large batteries capacity into a relatively small area, constructing a storage building while dealing with safety standards, manufacturer requirements, grid provider requirements, local authority requirements, auxiliary equipment, visibility and usage needs of the faculty, and more.
Fire safety has been a priority from day one of this project. Early on, we took in a firefighting consultant, and we realized we're going to have to build an entire dedicated building for these batteries. After we made the building, or we planned to make the building, we realized, okay, the batteries are going to produce a lot of heat. We need an HVAC consultant, and we need to put in these large fans in order to remove all the heat. Large fans, it means a lot of noise. So now we need an acoustic consultant, and so started a delicate dance where every minor design change has to go through a firefighting consultant, an HVAC consultant, an acoustic consultant, and also it has to be aesthetic, and we have to go through an architect. This means that we had a lot of iterations, but I'm very happy about the results. The project is a success because we went through this long iterative process with all the different experts. So we had some very specific requirements for this project. First of all, the basic control and monitoring of the batteries. But in addition, we're working with a microgrid. That means we need to have switches for going on-grid and off-grid. And the SCADA needs to control these switches. Also, we needed to communicate with a third-party optimization. And we also need to communicate with the owner and have the ability to control it locally. A key to a successful project is choosing the right partners. We chose Contel Smart Energy because we needed a professional partner that was going to be flexible. and would be willing to make changes as we learned more about the project. For example, halfway through the project, we realized that we need to add an additional module to control the HVAC, and Contel was happy to cooperate and to add this module. We needed somebody that was going to go along with us on this journey. What we got from Contel was not just an off-the-shelf product, it was a commitment to the project. Commitment to solve whatever problems arise and to make sure that the project in the end really works.
Contel Smart Energy is a division of the Contel Technologies Group, specializing in advanced supervisory control and data acquisition, energy management system solutions, tailored specifically for the renewable energy sectors. We serve a wide range of clients, including engineering, procurement, construction companies, independent power producers, commercial and industrial clients, and asset managers across various renewable technologies, such as utility-scale PV, standalone storage, hybrid plants, which include solar storage and conventional generation, agro PV, floating PV, and other type of dual-use solar projects. Today we manage hundreds of energy sites across Israel and beyond, representing more than 2 gigawatts of installed and under construction power and close to 2 gigawatt hour of storage. We use Ignition as our framework to build Energiny, our data-driven, cloud-based software for optimizing renewable energy from different power generation sources such as solar PV, traditional generators, or battery storage across different site configurations. Energiny is a central part of our product suite offering that combines hardware, software, and cybersecurity into an integrated system. We chose Ignition because it gave us a clear path to scale, a reliable industrial-grade core with the flexibility to build our own product layer on top. Its licensing model supports a multi-tenant SaaS environment without limiting us per tag or per site, and it integrates seamlessly with a wide range of hardware, protocols, and databases, which is essential in the diverse landscape of energy systems. Additionally, Ignition supports the advanced user experience and high degree of customization that energy management practices demand. It allows us to design intuitive, role-based interfaces, tailor dashboards per stakeholder, and adapt to the unique operational needs of each site, all while maintaining consistency across the entire portfolio.
We use Energiny for real-time control and real-time monitoring. And we have a consolidated platform for which we can monitor several projects. In addition, we have energy traders here in EDF office that will control the battery, and they will send a schedule for the optimal time of charging and discharging. We can also use it for gathering historical data and to analyze trends to get the optimal performance. And also an astronomical clock that can provide the exact date and time to disconnect from the grid.
The system is monitored remotely by an external O&M contractor and can also be accessed by our internal O&M team. The use is done mainly with Contel's web portal, which includes all the necessary gauges and controls.
Each site's PLC have a lightweight edge unit that connects locally to inverters, batteries, grid meters, and other sensors. It streams data securely to a centralized Ignition-based cloud via one-way MQTT over IPsec, where each site gets isolated access to its data without having to manage designated servers or IT. Our platform stays flexible, even when we onboard many types of energy sites. Since each site requires a different setup, our product Energiny brings together ground mount storage systems and hybrid sites equipped with diverse hardware from multiple vendors, and unifies them under a common operational logic. Whether a customer operates one site or 50, they get a unified, real-time view of performance, receive alerts for critical issues, and can take action directly from the platform. All under a mission-critical platform that enables faster issue detection, shorter intervention times, and overall improved operational continuity. Energiny provides a future-proof foundation. Customers can continue to scale without concerns about vendor lock-in or evolving regulatory requirements. The system is built to accommodate diverse hardware ecosystems and changing compliance standards, ensuring long-term adaptability and investment protection. Built as a SaaS platform from day one, improvements are continuous. We can roll out updates to all customers at once, whether it's a new model for battery optimization or market-specific integration. Every new site can be onboarded quickly with no need to redeploy infrastructure. Since the energy space operates under very different constraints, we had to rethink and adapt our development model to bring that same SaaS level agility into far more complex environments. For example, we recently released our new BI feature, which gives operators a real-time, cross-portfolio view of site performance, covering PV output, battery behavior, and grid exchanges. The rollout was instant across our entire customer base. No downtime, no local deployment, just immediate value.
Whether it's large solar PV sites, hybrid sites, or complex site configuration, Ignition adapts to every scenario and challenge.
As in every field, AI will play an important role also for storage. It can be used for analyzing data, for optimization, and also for predictive maintenance.
Regarding AI and future development, we recently developed an integration between Ignition and the large language model vendor in order to create an AI assistant that actually sits on top of our tags data.
Energy projects are becoming more complex. We see energy storage standalone, hybrid energy storage with PV, microgrids, energy storage providing more and more difficult ancillary services. And in this more complex world, we're very happy to have this cooperation with Contel, and we're looking forward to having many more projects together.
Looking ahead, we see Energiny playing an even bigger role for our ecosystem. We're already planning a number of initiatives that will take full advantage of its flexibility and scalability. We're also building data science modules to perform advanced analytics and extract deeper insights from our operation data, not just for optimization, but also to inform smarter decision-making across the board. Energiny is more than a traditional SCADA and EMS. It's a unique innovation platform.
In the future, we're going to add PV to this project, and we might also add more ancillary services if the grid provider requires it. Prepare for the unknown. A battery project will be alive for maybe 15, 20, 25 years. And throughout the lifetime of the project, it will provide different services. And therefore, you need a SCADA system that will be able to be flexible and provide different services as the requirements change throughout the lifetime of the project.